This video is over section 2.7, limits approaching infinity. And in this video, we're going to go through an example of how to find the horizontal asymptotes of a function. Now, if you watched the last video on this section, you remember that we went through 3 different ways of how we can approach these types of problems. We can solve these problems mathematically, conceptually, or using rules. In this video, we're going to go through how to find the horizontal asymptotes of this function. And if you remember, the way that we solve limits as they approach infinity is actually the same way that we solve for horizontal asymptotes. So we're going to go through this problem those same 3 methods. So let's start with our first way, just going through this problem mathematically. If we're looking for the horizontal asymptotes of a function, we're going to solve it the same way we did for limits approaching infinity. We go to our denominator, find our highest power, and divide every term by that highest power. So our highest power in the denominator is x squared. So I'm going to go through, divide every term by x squared. And once I do that, I go through each term, cross out like terms, and see what I have left. So on the top here, my x squareds, they cancel, so I'm left with just 3. Over here, one of the x's cancel. I'm left with minus 1 over x. Then over here, remember, if you ever have a number over x, no matter what the power is, you can just cross out it entirely. That becomes 0. So plus 0. Over on the bottom here, x squareds cancel, so I'm left with 2. Minus 6 over x squared, one of the x's cancel, 6 over x. Plus 11 over x squared, that becomes 0. And looking at what I have left over here, I still have a number over x, so cross these out, those are 0. And now all that I'm left with is just 3 over 2. So after that method, I can see that my horizontal asymptote of this function is the equation y equals 3 over 2. All right, so there's a mathematical way of how to solve this problem. We went through, divided each term in our function by the highest power in the denominator, and saw what was left over. Now, using our second method that we went through, if we were to just memorize those rules that we learned in the last video, well, we look at this function and we see the highest power in the numerator is x squared, and the highest power in the denominator is also x squared. So since I have the same power in the numerator and the denominator, the horizontal asymptote is just whatever these coefficients are. And like we saw, the highest coefficient in numerator is 3, highest in denominator is 2, and when we went through and solved it mathematically, that was the equation of our line. It's just the leading coefficient in the numerator over leading coefficient in the denominator. All right, and our third and final way of how we can think of these problems is, let's just think about this conceptually. So going back to our highest powers, in our numerator, our highest power is x squared, and in our denominator, our highest power is also x squared. 3x squared, 2x squared. When you're thinking about limits as they approach infinity, you're only concerned with the highest power because that's what's going to carry the most weight on both the numerator and the denominator. So everything else we can just cross out. We're only worried about these terms. And thinking about this, really similar to when we looked at the rule in the last step, the x squareds, they're going to end up canceling, and all that you're left with is the coefficient. So whether you solve this problem mathematically or you just remember the rules that they have the same power in the numerator denominator, so it's just the ratio of the coefficients, or if you just thought about it conceptually, you'll end up getting the same answer either way, and that's y equals 3 over 2. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.